Hello everybody, it's Haresh here. Today we're going to be learning about how to identify like terms. So like terms is basically the same variable as well as the same exponent. So as you can see right here, we have an x variable as well as we have an exponent to the power of 2. As well over here we have an x variable and then an exponent to the power of 2, and here we just have an x. So we're going to be identifying like terms and learning how to add and subtract like terms. So let's start off with this first example. So let's try it for addition first. So we have x squared, we have 2x squared, and then we have 5x. In order to collect like terms, we would have to have the same variable as well as the same exponent. This x2 squared is the same thing as x2 squared right here. They both have an x, and they both have an exponent of 2. So these terms we can simplify and collect like terms. But for this x, we only have an x. We don't have an exponent of 2. So this has an exponent of 1 actually. So we cannot collect like terms. So let's try collecting like terms for the first two terms, and then we're going to add this on to the second part of this expression. So we're going to have our x squared plus, so we're going to do our addition first, or we're going to try with addition first. We're going to have x squared plus 2x squared plus 5x. So then this results in x squared plus 2x squared. Isn't that just 3x squared? And then we're going to add 5x since it's not a like term. So that's about it for the addition. Let's try for subtraction. So what if we subtract x squared from 2x squared? So x squared minus 2x squared. Oops. Let's write that better. 2x squared minus 5x. Well, x minus 2x squared, isn't that just x squared? Or you can say negative x, right? So we're going to get a negative x. Because basically this is like a 1, right? And it's like we're saying 1 minus 2. Well, 1 minus 2, isn't that negative 1? So this is going to result in negative x squared. And then we're going to add this negative 5 to the end part. So that's how we do it. Let's try for one more example where we're going to have x squared to the y squared to the z squared plus or minus x squared to the y to the z squared plus or minus 2x squared to the z squared to the y squared. So let's try this example. So let's only try this for addition in this form. So let's add on both sides. So let's see what variables are similar to the variables in this expression. So we have an x, we have an y, and we have a z. We have an x, we have a y, and we have a z. X, y, and a z. Now let's take a look at the exponents. So here we have an x squared, we have a y squared, and a z squared. But only here we have an x squared, we have the y to the exponent 1, and you have an z squared. Okay, so that doesn't match the first one. Let's check this one out. We have an x squared, we have a z squared, and we have a y squared. This z squared is actually in the middle. It's kind of throwing me off, so I'm thinking that this is not the same. But actually, it's just the order is different, but it's the same exponent and same variable. So that means that we can add the first term and the last term together, but we have to leave this second term by itself because it has y to the exponent 1. And the rule is, in order to collect like terms, we would have to have the same variable as well as the same exponent. So let's try adding all these terms together and see what our result is. So x squared plus y squared plus z squared. And then this one also has a coefficient of 2. So if we add one of these, right, remember there's an imaginary 1 right here, we're going to get 3. So we're going to get 3x squared to the y squared. And then the z, we can just move it back to the original spot. If you guys don't like the regular format where it's like the z is in the middle, you can just say x squared, y squared, and then z squared. It's still going to be the same value. The variable still retains the same value. It doesn't change if you move the numbers around, as long as you are not changing the operations. The answer will stay the same. So if we add that to this term right here, so our final result is going to be x squared y to the power of 1. We don't write the 1, and we're going to get z to the squared. So this is going to be our final answer when we add. Okay, and then let's try one more final example. So this is more of a complex example. It's kind of hard actually. Okay, so let's try the example. Let's see what variables we have in the first place. So what I can see that we have an x, we have a y squared. Okay, we have an x, we have a y, we have a y and an x, we have a y and an x, and we have a y and an x. So they all have y's and x's. So that's how we know we're on the right track. Now let's take a look at the exponents. So the first term has an exponent to the power of 2 and a y exponent to the power of 2. We're going to leave this one here. It doesn't have an exponent to the y. 2 actually has an exponent to the power of 1. Let's try the third term. So this one actually does have an exponent to the power of 2 and an x to the power of 2. And the fourth term, it actually has an y to the power of 1 and x to the power of 1. Sorry, y to the power of 2 and x to the power of 1. But this final term has y squared and x squared. So the first term, the third term, and the last term are like terms. So we can try that first. So let's see what result we get. Remember, we're still following our order of operations here, and if you guys want to call it BEDMAS, or you can call it PEDMAS, it's really up to you. They're all going to be the same thing. For PEDMAS, it just means parentheses, and for BEDMAS, it's just brackets. So, or actually, you don't need this final S right here. Never mind. Okay, so let's add first. Let's start off with adding. Remember, in PEDMAS and BEDMAS, we add first, right? So we're going to add first. So 3x squared to the y squared plus 2y squared and x squared. So if we do 3 plus 2, right, if we add the coefficients, we're going to get a 5. Because 3 plus 2 is 5, right? And then for the variables are going to stay the same. They still retain their value. We're not multiplying or dividing here, so we're not going to add the exponents. We're going to keep the exponents the way they are and retain their value. And then we're going to subtract y squared and x squared. So we're going to keep that there, but we're not going to continue with the calculation until we do all the addition first. So that we're not confused, right? We don't want to get confused, so we're going to do all the addition first. So now let's try the second part of this expression. So remember, we left this x to the power 1 and this y to the power of 2. And if we look here, we have 2y to the power of 2 and x to the power of 1. So this is simply like terms. So let's try adding and subtracting. So we have an x to the power of 1 and y squared minus 2y squared and x to the power of 1. So isn't that just going to be negative y squared? And then x to the power of 1. We're not going to write the 1 because it's bad form. So remember, the order of the variables doesn't matter. As long as the exponents are the same and the variables are the same, we're still going to get the same answer. So let's further simplify. Since we have like terms here, the same variables here and same exponents here. So 5 minus an imaginary 1, well, isn't that 4? And then we're going to keep our variables and our exponents. So we're going to get 4y squared and x squared. And then this term right here, we're just going to keep it. We're going to add it to the end. So y squared x. So our final answer is actually 4y squared x to the squared minus, actually let me write that better, minus y squared x. So I hope you guys found this video useful, and definitely subscribe for more content like this. Have an amazing rest of your day.